During the turn of the century, Nikola Tesla had this idea to send wireless power anywhere around the planet. How we wanted to do that was set up a standing electromagnetic wave that would reverberate between the ionosphere and the ground and travel around the world, and you would be able to tap energy out of this. Well, that idea didn't really work out, but it gave us some inspiration for ways to set up wireless power in large spaces. So what we're going to do is we have a metallized room, and we're going to use standing electromagnetic waves that reverberate all around this room, providing wireless power to any device inside. There are a variety of forms of wireless recharging. One of them is rechargeable toothbrushes, where you have your toothbrushes placed in a little charging cradle and it provides one dimension of charging. Another form of wireless recharging is wireless charging pads, where you can have a cell phone that's placed anywhere on that pad. But what we really want is a three-dimensional charging experience where you walk into your living room or office and your cell phone is charged simply by walking in.
The way we're trying to address this problem is by building large metallic structures and filling them uniformly with magnetic fields. From these magnetic fields, we can couple power out to specially designed receivers. So the room that we've constructed is your standard rectangular type of room, except that the wall, ceiling, and floor are all made from aluminum panels. Into the middle of the room, we've inserted a long copper pipe. And in the center of that copper pipe, we've actually cut a small gap into which we insert discrete capacitors. And it's those capacitors that set the electromagnetic frequency of the structure and confine the electric fields.
Since magnetic fields don't interact strongly with everyday objects, we're able to place tables and chairs and everyday furniture in our wireless power room without affecting power transfer.
At the resonant frequency, currents travel up and down the pole at 1.3 million times per second. Those currents travel through the ceiling, down through the walls, and back down to the floor, where they again flow up through the pole. It's those currents that generate magnetic fields that circulate around the pole. One of the remarkable things about this room is that with the appropriate receiver design, we can actually power many devices simultaneously. Because of the way the magnetic fields swirl around the pole, the initial receivers we designed need to actually be oriented perpendicular or orthogonal to the magnetic field swirling around the pole to receive power. If they're oriented parallel, they receive no power. To gain orientation independence, we took 3 coils and put them into a 3-coil orthogonal system such that at any orientation we can receive power.
In this work, we're demonstrating room-scale wireless power, but there's no reason we couldn't shrink this down to the size of a toy box or a charging chest, or scale it up to a warehouse or a large building.
Our simulations show that we can transmit 1.9 kilowatts of power while meeting federal safety guidelines. This means it's completely safe for people to occupy this space for any amount of time.
My name is Lance Sample, and I lead the Wireless Systems Group here at Disney Research.